Hello, everybody.
Hi, everybody.
Hey. So we want to start by asking a question. What if we told you that you could increase your Android app's reach to millions of new customers?
Sounds like magic, you know?
Right? No, not magic, Gio. We're going to tell you today how you can expand your Android app beyond the phone. I'm Anisha.
And I'm Giovanni.
And we're developer advocates at Amazon. And today we're going to take you through a journey of how you can bring your app to millions of new users, customers, and how you can do that and how you can get your app in front of millions of new people. So as developer advocates, we're both engineers, Android engineers, just like you. And here's a stock photo of Gio to demonstrate. Okay. I don't know what he was building, but I'm sure it was something cool.
An Android app.
An Android app? Can they see this Android app later?
Later, at our dev booth.
Oh, good plug, Gio, good plug. So as a developer, you build your epic app, you deploy it on an app store, or maybe you already have an app, but you're hoping.
Who can tell me what are you hoping for after you deploy an app in the App Store? Has anybody the answer of this?
No. Exactly. You're hoping for users, and you're always going to want more users, aren't you? Because when you increase the adoption of your app, you increase your revenue, and you make your app a success. So what's a good way to increase your number of users? Think about deploying it to another app store. An app store running on millions of devices, different kinds of devices, each one with a specific use case. From the tablet, to the TV, to the car, and now to the desktop. We have millions of use cases for every day. And that's the Amazon App Store. So how can you, as an Android developer, publish your app to the Amazon App Store? Well, it's really quite simple, actually. First, you just go to this website, developer.amazon.com, and that's it. Create your developer account. To create your developer account, it's free. There's no hidden fees. And Amazon App Store provides localized support if that's what you need. So let's say you already have your Android app developed. If your app doesn't require Play services, you can just upload it straight away using the web console as shown on screen. So if your app is using some Play services or other App Store services, don't worry.
Yeah, because we have got you covered. Let's say that you have to use feature like in-app purchase. With the Amazon App Store SDK, you can implement this feature, and this feature can be compatible with the Amazon App Store. With the Amazon App Store SDK, we are supporting in-app purchase and DRM. So in-app purchase with the feature you're already working with, so consumables, entitlement, and subscription. And DRM if you need if you have a paid app and you need to protect the paid app. Adding the dependency of the Amazon App Store SDK is super easy. I mean, you're already used to add a dependency in the build.gradle file, so just add this line in the same file. And then you have to implement the core API of the Amazon App Store SDK for the in-app purchase. So just implementing the methods coming from the purchasing listener. The purchasing listener is defining 4 of the main methods that are the core of this API. Using these methods, you can access all the information you need about your purchases and your user purchases, like the information about your user, the information about the purchases, the information about updates about the purchases, and so on.
But Gio, we're talking to developers, so what about testing?
Yeah, that's an important part of the development phase, the testing phase is an important part of it. But we can help you testing the in-app purchase with our app. It is called App Tester. This is available on the Amazon App Store, and you have just to download it and install it on your Fire device, and you can actually test with your in-app purchase in a virtual way, like you are doing actually the in-app purchase for real. And it's easy configurable by JSON file. So you have just to download, you have to define your in-app purchases on the Cloud Console, download the JSON file, install it in the device that is running the app tester, and that's it, and you can run it. And also, we are offering the possibility to define promotion for your user. And from the Amazon App Store Cloud Console, you can define promotional pricing, introductory pricing, and then you can define a time-based offering for the subscription for your user. But what about another key feature of the Android apps, like the push notifications?
Yeah, so don't worry. Again, we've got you covered. If you want to send notifications to your users, we've actually got 2 SDKs you can use. So we've got our A3L SDK and our ADM SDK. So ADM is the SDK, so Amazon Device Messaging, that handles push notifications specifically to Amazon devices. A3L is an SDK that you use if your app is also supporting Firebase Cloud Messaging, because it's actually an abstraction library that supports both ADM and Firebase. So again, it's a very familiar SDK. I'm sure you probably have seen something similar. So when you're implementing the A3L SDK, the first step is to extend the A3L messaging service class, which is part of that A3L messaging SDK. And this is what allows your app to receive messages. Then you'll need to overwrite two methods. So the first method you'll have to overwrite is the onMessage received when a message is delivered to your app instance. Once you've extended that one, the second class to extend is the onNewToken called, which is when a device ID for the app instance is ready. And you'll probably need to log this or keep this for testing purposes, which we'll see in a second. So once you've done that, you need to update your app's manifest file to receive messages. So you'll need to declare your implementation of the A3L messaging service class as a receiver, as this is what allows you to handle the registration and method intents that we saw earlier. So this is an example, and the My A3L messaging service is just like a placeholder, so you can have your implementation of your class if needed. And finally, in the onCreate method, you initialize the A3L messaging, and in the onReady, you can retrieve the device ID we saw earlier. And again, this is important for testing because we know you'd want to test. So you need a device ID where you installed your app. And once you've got that device ID, again, we've got you covered when it comes to testing. So you can test those push notifications and use the testing tools available on the developer console. So as you can see here, you can fill out all the fields that you need, and as needed, you can put in the device ID and the important bits of the message that you will need to test.
Great, yeah.
So I told you before that we support many different devices, but you've only seen one so far. So what about the rest, Gio?
Yeah, now we see another one. I mean, the Fire TV family of devices. We run Fire TV on the Fire TV Stick, on the Fire TV Cube, but even we run the Fire TV software on Smart TV as well. So with Fire TV, you have the opportunity to have actually your app in the living room of your user. Fire TV is like in over 60 countries. I always forget the number, sorry. But
yeah, I think it's 60.
And over like 150 million of devices sold. So like a super big user base that you can like have for your app. And since last year, we are running Fire TV also in the car. So we have Fire TV for car. So actually, you can allow the user of your app to run your app even on the car. So you just need to develop the app for the Fire TV, ask us how, we are the developer booth downstairs. We're gonna share with you some code there. But we also have like other things to talk about. Like, I want to tell you this story. Like yesterday, I was working to this presentation and I was feeling so bored. And I said, okay, no, I'm like, I need some break. And then I took my phone from my pocket and I started to play a game.
Gio, you can't be saying this. Our team's sitting right there.
Okay, sorry guys.
Yeah. But it's okay, don't worry. I have an idea for you. So now you can play your favorite games on desktop. So you can do it at work and no one's gonna know. So with the Amazon App Store, you can run your Android apps on Windows 11 devices. So as developers, I'm sure you're wondering how you can play games at work. I'm just joking. I'm sure you're wondering how you can become part of this opportunity. So the technology that makes it possible is the Windows subsystem for Android. And to test your apps, there's just two prerequisites you need to make. So the first one is you have to have a Windows 11 device and an Amazon account registered in the UK. If you don't already have one, my question to you is how do you do your shopping? The second one is Windows 11 specific requirements, so like 8 GB RAM SSD storage. And those specific requirements can be found on that link on screen. But just those two requirements. And once you meet those, you can go ahead and test your Android app in a Windows environment in literally 3 steps. So first step, install the Amazon App Store. And while this is happening, Windows subsystem for Android will silently run in the background. So Microsoft Store will run the Windows subsystem for Android install in the background, so you won't have to do anything. And once it's installed, you can log in with your Amazon account. And just remember that one thing is you do need an Amazon account to have an Amazon developer account. Next, you need to access the Windows Subsystem for Android settings app. So to test and debug, you'll need to click on the menu icon and go to developer options, and then toggle developer mode to on. So yeah, there, once it toggle on and off for your developer mode. And if you prefer not to leave Android Studios, don't worry, we've got you covered again. So you can access your Windows Subsystem for Android emulator just as you would on Android Studios. So you need to run an ADB connect command with the address for the local host as the one on screen. And then you'll see that, well, if the screen works, you'll see that, oh, sorry, technical difficulties. There we go. So I'll just start that video again. Oops. Sorry, guys. Yeah, there we go. I think that should be, yeah. So once you connect with ADB, you'll see that the device pops up at the top as you would with any other emulator. And then you can go ahead and run your app on the emulator. So that should pop up in a second. There we go. So that's our demo app that we have on display downstairs as well if you want to come and see. And once you've run your app, you can use all the developer tools that you're probably familiar with. So you can scroll down, you can see all the normal Android developer tools are available as you'd expect. We can turn on the layout bounds, and you can inspect your app as you would as if it was any other emulator on Android Studios. So
Okay,
yeah, again the screen. So sorry.
Use the keyboard.
Yeah. So while you don't have to rewrite your app to bring it to Amazon devices or to Windows 11, you don't have to. There are some best practices and optimizations that you can make to your app for no matter what form factor you're using. So whether you're bringing it to the Amazon App Store, whether you just want to make your app more optimized, for the largest screen. So we've got a couple of tips and tricks. So hopefully you can take this home and implement it to your app. Some might be Amazon specific. Some might just be for making your tablet experience better. So we'll take you through a couple of them. And if a lot of these are useful if you want to port your app, especially. So we'll run through them real quick.
Yeah, let's see the Amazon specific one.
Yeah.
So if your app is relying on services dependent from other app store, like Google Play services or other, these services will not work on the Amazon devices. So you need to understand programmatically where your app is coming from. And there is this API, package manager, get installer's package name, that can help you with that. So if this API, if this method is returning to you com.amazon.venezia, that means that the app is installed by the Amazon App Store. And then you can programmatically select which services you want to enable. Let's say you want to enable the in-app purchase that we explained before from the Amazon App Store. So you need to put if this com.amazon.venezia, enable that in-app purchase. And that's super trivial. Then, because we are running, if you are running our app on Windows 11, we need to know that Windows will run the app on a free-form window. So let's say, like the other app that the Windows user are used to run. The minimum screen requirement for your app window will be 1280 by 720 pixel. You can override this by modifying and forcing your size inside the Android manifest. So pretty simple as well. And because also your app will run on a window, the app needs to support the snapping feature of Windows, or Microsoft Windows. So it means that the user can drag the window of your app on the left side, and then the window will be make it bigger, and then will occupy the right side of the screen. So you need to make sure that the user interface of your app is responsive. And this is something that we as Android developer are used to like if you are thinking how our app running for the tablets. But nowadays, like this kind of issue is expanding because we have a lot of devices, a lot of screen to support. So let's see how we realize that a demo with thinking about the responsive UI.
And these things can be used for any app, right?
Yeah.
So if you've got your mobile app and you want to port it to tablet, what Gio's about to go through would work for anything, really.
Yeah, in the specific we use for our sample Jetpack Compose. Jetpack Compose is like helping a lot the developers to understand and design and develop responsive UI. In the specific case, we use the Material Tree Windows Sites library. Just add the dependency line on the build Gradle file. And now we use the API calculate Windows Sites class to understand, to extract the width of the window that the app is running in. In this case, like you can decide, to adapt the UI as long the window width is like compact, extended or medium, expanded or medium. And then we pass that as an argument in the composable tree, in the composable hierarchy. In the specific, we use the width size class to understand if the screen is expanded. And then if the screen is expanded, we show or hide a drawer, we show or hide a list of the video that we are like representing, like we are displaying in our app. I want to show you the demo. Start the video. Doesn't start the video.
Yeah.
Here it is. You can see the demo anyway. Our developer boot is the code is open source, so you can also check it and play with us with the demo. So in this case, we use the is the window expanded by Jetpack Compose API, and then we show the drawer. That's it. And yeah, you also need to, the UI is not the only problem. We know as an Android developer, like if you are changing the UI, it's not only a graphical thing to think about.
Yeah, so we need to think not only about our dynamic changes, but also about configuration changes. So that, well, if you do or don't know, but when you change the configuration in your Android app, that activity will be destroyed and recreated. So there are a few ways that you can handle this. So like say your user is like turning their tablet from portrait to landscape. Your app activity is probably going to be destroyed and recreated. So you want to save the state, right? So there's 3 ways that you can persist storage and save the state to restore your UI to the previous one. So you can use onSave instant state for your activity fragment view or save state handle for your view model. Or you could use the new composable remember savable to make sure that if there are configuration changes, your user is having an experience where it's not disconstructed and the UI save state is persistent. If you're brave, you can use the on configuration change method to handle the window resize changes yourself. So you can add this line to your manifest file, which is basically saying, hey, don't restart my activity when these following changes happen. So if I change my orientation or my screen size, don't, as the app, don't handle it, but instead I will specify, in my method how I want to handle them. And finally, don't be this person that says, you know what, I don't care. I'm just going to place my app in compat UI mode because that's not going to be a great experience for any user. So yeah, don't be that person. When it comes to input methods, Android apps should consider keyboard, mouse, touch, and now pen as input methods for the best user experience. So in specific to Windows subsystem for Android, that supports the pen too. But regardless of what your user is using, regardless of what app, phone, there are so many more input methods that we now have to consider. So many existing Android apps, I'm sure you already support keyboard and keystroke use cases. So if you're playing a game, you'll be used to being able to use WASD alongside touch as your input method. But in terms of mouse, there are specific scenarios that are automatically covered in Android, such as scroll wheels, dragging, selecting, highlighting with the mouse. And these are often automatically supported. But we do recommend, no matter what form factor you're using, just to test this out. So Windows Subsystem for Android specifically reports mouse down up events as touch events by default. However, if you want to check if your text is focused, that input is reported as mouse events too, to ensure like text highlighting, cursor placement works as expected. And for actions such as right clicks or hover effects, you may want to include optimizations specifically for these, which Gio is going to talk to you about.
Yeah, let's see how we implemented, we handle input devices in our demo app. So Android is already handling for you a lot of inputs coming from the keyboards, like the normal letters, the key letters of the keyboard. But let's say you want, you are on a desktop, you are on a laptop, so you want to give your user the possibility to navigate your app with the arrow keys, or because your user is using a normal keyboard, is already using control-based shortcuts, like Control F, Control S, and so on. So to use these, you need to programmatically code and handle this kind of event. This is a demo app showing that the normal input control from the keyboard are handled by the Android platform. In our sample, we use Jetpack Compose as well. And to capture the event coming from the keyboard, you can just use a modifier. A modifier is just something that you can associate to a composable to extend, to decorate the behavior of that composable. In this case, with this modifier, you will be able to capture the event of a key pressed. And with the onKey event method, we are just passing what will be the behavior associated to the pressed action of the keyboard, of the key. And because the modifier can be concatenated by themselves, can be aligned, you can actually assign to a composable a lot of them, and you can say this edit field will handle the enter key event from the keyboard or the escape key event from the keyboard. Let's say that I want to start a search if I press enter in an edit field, or I want to clear the field if I press escape. We also talk about the mouse. The mouse event, you have the left side of the left button of the mouse and the right button. So let's say that you want to associate a function, a behavior to your composable associated to the right press of a button. You can use this modifier, like extending a pointer input modifier of Jetpack Compose. And inside that method, you can extract what kind of button has been pressed by the user, just getting events button is secondary press Boolean. And with that, you can give and assign the behavior that you want. In this method, I use block as a left side behavior method for the left button of the mouse, and block right, the method, the action corresponding to the right side of the to the right click of the mouse. And because on a different form factor, like the laptop or the normal computer, you might want that the user interface react to hovering event. So when the user is moving the mouse and moving the cursor on top of your widget, UI, or composable, if you're using Jetpack Compose, you might want to use the hoverable modifier to maybe assign a new border color on the widget that you are handling. In this sample, we use the modifier to change the border color from blue to red if the user is moving the cursor inside the picture. But another important part of an Android app are, like I said also before, are the notification. What about that, Anisha?
Yeah, so I think we've covered a few topics that are, either Windows 11 specific, or you can use them for any of your apps. This one is a bit more Windows 11 specific. So I'm sure your Android app is probably sending notifications to your users. So when this is happening on Windows 11, Windows handles these as it would as if you were sending them on your Android device. So it mirrors and mimics them. So as you can see here, this is again our demo app. So this is just a basic notification. You can have an image one, which will work exactly as you'd expect on a Windows device. And you could have your progress notification, which again same bottom right-hand corner is what a user would be used to, is what a user would expect to see. And so this happens automatically. So if you're bringing your Android app to Windows 11, you don't have to change anything when it comes to notifications. And finally, we're going to touch a little bit on APIs and services. So if you're thinking of porting your app to Amazon, we have our APIs and services that you can easily use to bring them over. So it's an equivalent suite of APIs that you're probably used to. So for example, if you're using Google's Play services for like billing, we have the Amazon in-app purchasing API, so the App Store SDK. If you're using cloud messaging and you're using Firebase Cloud specifically, you can use our abstraction library, so you can have your messaging happening through two ADM and Firebase at the same time with A3L. If you're using Firebase SDK, you can use the JavaScript SDKs. And finally, if you're not using Firebase, you can use in-app messaging and specifically our Amazon device messaging SDK, so ADM. So there are a full suite of equivalent services. So we try to make your porting experience as easy as possible, whether you're porting it to Windows 11, whether you're porting it to Fire TV, tablet. We want to make sure that you can get your Android app in front of as many users as possible. So if you're not already developing for the Amazon App Store, come find us. We can help you get there. And hopefully these tips leave you with something if you're just thinking of porting your device or making sure that you support different form factors. So I think that's it from me and Gio for today. This QR code has all the links that we've spoken about today, links to our socials. If not, you can find us downstairs. We've got a booth where we can show you the demo apps that we spoke about today. If you need extra help porting, or if you're just more curious, Gio's got a great demonstration for all the hovering effects.
We also have demo apps related to the porting and using A3L for push notification, for in-app purchases, so going from the Google in-app billing to our App Store SDK. So come to our developer lounge, because it's a lounge. We have a comfortable sofa in it. And and let's have a discussion about reading the code.
Yeah, and if not, just find me and Gio. Our Twitter handles are there. You can find us, or you can find us later, whichever you prefer. But thank you so much.
Thank you.